Hello, I'm the representative for Team IoT Nexus. We're trying to increase the ability for IoT devices to adopt blockchain technologies. Currently, IoT systems have standardized data packets that are very efficient with Web2 infrastructure. However, these data packets are not compatible with current VMs that are used in blockchains, such as the EVM. This project presents the idea for custom VMs to be created. We enable the idea of having blockchain with custom VMs by showing that we can efficiently export state proof of blockchain by using a cryptographic technique called compact certificates. This cryptographic technique was first presented in the paper Compact Certificates of Collective Knowledge by Macaulay. The paper gives us these three advantages when using compact certificates versus never used certificates. First, we can use a large amount of attesters. And second, when using 1 million attesters, the verification time is 3,000 times faster. And when using 1 million attesters, the certificate is 400 or 150 times smaller than a naive certificate. Compact certificates are currently being used by Algorand when they are generating state proofs. This application helps our consensus mechanism become post-quantum secure. Here's the general system overview we propose in our white paper. We have users running light clients, collecting data and validating with full clients. Someone calls for a CC to be made, signatures are collected and organized. The compact certificate is then created, verified, and submitted to this chain, while a relay contract can submit the proof to a target chain. We will go into more detail about what we achieved in this project, as seen in the red box. To create the CC, we set a threshold of weight we want to achieve with the vote. We then initialize the vote and collect till the threshold is met. This is done by taking the most recent signed weight number and adding their weight to it. After the threshold is met, we commit to the attesters and their weights in a Merkle tree we call the ground truth, and commit to the signed message and their weights in another Merkle tree that represents the vote. After this, we create a mapping that we will deal with in the verification. To verify, we must check 5 things. First, in the mapping, we must check that the actual threshold was met, that all of the Merkle paths created are valid in the attester and ground truth trees. Check that the signature is valid under the allowed people to vote, and make sure that the coin is in the correct range. Of course, this is a brief overview. More details provided in the original white paper. Here's a demo of the process being worked. We're going to show that the certificate that we generate, the proof that we generate, and all of the valid attesters that participated in the vote. What we really care about in this process, as we timestamp everything, is that the verification process aligns with what is given in the white paper. This project shows that custom VMs could be created for IoT devices to use the current data packet protocols by showing that we can efficiently export the state proof of a blockchain, which would make their adoption of blockchain technologies easier. Other general applications of this project are asynchronous voting on chain, verifiable weighted votes across chains, and having a large amount of attesters in any vote on chain. Thank you for your time. Our technical documentation, code, and white paper with more detail can be found in the GitHub we provided.